everyone, welcome back to my channel. Today we're going to be learning about the unit circle. The unit circle is a complex yet fascinating thing. I'm excited to teach you about it today. Look at the circle on the screen. I can divide it into 4 parts like so. You may recognize this looking like a graph with 4 quadrants. Let's do a refresher and label the points on each quadrant. This point here would be labeled as 1, 0. This point here would be labeled as 0, 1. This point here would be labeled as negative 1, 0. And this point down here would be labeled as 0, negative 1. One key thing to understanding the unit circle is what I'm going to say next. The coordinates of the points on the graph. The x-coordinate is going to be equal to cosine, and the y-coordinate is going to be equal to sine. Please keep this in mind as we continue with the lesson. A quadrant can be split in many different ways. However, 2 common ways are by splitting it into thirds or splitting it into half. Remember that each quadrant is equal to 90 degrees, so when you split the quadrant in thirds, each new triangle that is made is going to have one 30-degree angle. If you split a quadrant in half, each triangle that is made is going to have a 45-degree angle. Let's pause here and examine these 2 different types of triangles. These are 2 different common types of triangles. One is called the 30-60 triangle. In this triangle, one angle is 30 degrees and the other is 60. The other is called a 45-45. This means that one angle is 45 degrees and the other one is also 45 degrees. There are some special elements about the relationships between the lengths of the sides in these triangles. So in the 30-60 triangle, if the hypotenuse is labeled as x, the shorter side is going to be labeled as 0.5x. And the longer side is going to equal 0.5x times the square root of 3. In the 45-45 triangle, if the hypotenuse is x, the 2 other sides are x divided by the square root of 2. Of course, there are other ways of writing these equations, but for today, we are going to refer to them as was shown on the screen. These formulas are very important as they can help you quickly find the sides of unknown angles without having to do the Pythagorean theorem just by knowing these relationships. This will help on standardized tests like the SAT, ACT, and not to mention like on regular math tests or geometry tests to help you solve these problems quicker. Let's go back and look at what I said earlier about the x-coordinate being known as cosine and the y-coordinate also being known as sine, and put this in perspective. Let's look at the point right here, which we will label as 1, 0. From our starting point, which is always going to be 1, 0, to this point here, which we will label as 0, 1, we can see that this makes a 90-degree angle. By looking at our ending point, which is 0, 1, we can see that 0 would be the cosine of 90 and 1 would be the sine of 90. We can see this because our ending point here, this 0 is the cosine and this 1 would be the sine. And since we have a 90-degree angle, the cosine here of 90 would be 0, 1, and the sine of a 90-degree angle that is made would be 1. Feel free to try this out with the rest of the points on the graph as well. Another thing I'd like to point out about this concept is when the value of sine, cosine, tangent, and their reciprocals are either positive or negative. Also, just as a reminder, tangent is equal to sine divided by cosine. If you're looking around the graph, you can see that sometimes the values are negative or positive. For instance, if we were to do a 180-degree angle to our point over here at negative 1, 0, we can see that the cosine of a 180-degree angle would be -1 instead of 0, like it was here. And the sine of a 180-degree angle would be 0 instead of 1, like it was in the 90-degree angle. The last thing I want to explain to you is the reason why this is called a unit circle. The reason behind this is because the hypotenuse that is created in these triangles is always equal to 1. The directions say to write each of the following as a function of an acute angle. Let's look at the first problem. The first thing we need to do is find the reference angle. The reference angles are the angles that are made with the sides of the quadrants 90, 180, 270, and 360. All of these are reference angles. The closest reference angle to 216 is 180. Here is 180. Since 180 is smaller than 216, we're going to do 216 minus 180. 216 minus 180 equals 36. This is the first part of solving the problem. The next part is deciding if our answer is either positive or negative. We know that the angle 216 is in the third quadrant. If we go to a table, which you can see on the screen, we can see that for cosine and for quadrant 3, our answer is going to be negative. So our final answer is going to be negative cosine 36 degrees. We have answered the question because the answer is an acute angle. Let's try number 2 now. Since -17 is already an acute angle, we do not need to find a reference angle. However, we do know that -17 is in the fourth quadrant. This is how we know that. If we look at a graph and we go to our starting point here at 1, 0, and we go in a clockwise direction, we know that from here all the way over here is -90 degrees. Since in the problem we are told that is -17, we know that -17 is just about here in the fourth quadrant. If we look at our table, we can see that for sine and the fourth quadrant, our answer would be negative. So our answer is simply going to be negative sine of -17 degrees. Now let's try this problem on the screen. Please do not worry about the cotangent part of the problem. This frankly does not make a difference about how we are going to solve our problem. First, we need to find a reference angle for 287.1. 287.1 is closest to 270. Again, we are using the numbers 90, 180, and 270 because these are the points that are made for the different quadrants in a graph. So 287.1 minus 270 equals 17.1. This is the first part of our answer. We know that the angle 287.1 is in the fourth quadrant. So if we go to our chart, we can see that for cotangent and for the fourth quadrant, our answer will be negative. So our answer is going to be negative cotangent of 17.1 degrees. Now we're going to learn how to answer questions that are asking us to find the exact value of the trigonometric functions. Let's look at the problems. Number 1 says 315 degrees. So the first thing we need to do is find a reference angle. We don't exactly need to know if this is sine, cosine, or tangent, but rather what type of angle is it? Is it a 45-45 or a 30-60 triangle? Well, in this particular case, we can see that this is a 45-45. We know that because our last digit ends in 5. However, if you still do not know the answer by looking at it like this, we know that our closest reference angle is either 360 or 270. In this case, we'll do 360. 360 minus 315 equals 45. So we know that the triangle that is formed here is a 45-45. Now let's look back on the equation that we have for a 45-degree angle. This equation says that when the value of the hypotenuse is x, the value of this side is x, divided by the square root of 2, and the value of this side is x also divided by the square root of 2. Since this is a unit circle, our hypotenuse value is always going to be 1. By looking at the equation, we can see that the other sides, x and y, are going to be 1 divided by the square root of 2. However, since the square root of 2 cannot be on the denominator, we are going to rationalize it. We will multiply this fraction by the square root of 2 divided by the square root of 2. And the square root of 2 times the square root of 2 equals 2. 1 times the square root of 2 equals the square root of 2. So our final answer is going to be the square root of 2 divided by 2. So now that we know our x, y, and r values, all we need to do is plug them into the right equations. Once again, if we look at a triangle on a graph, the hypotenuse will be labeled as r. This side will be labeled as x. And this side here will be labeled as y. So we know that our r value equals 1, our x value equals the square root of 2 divided by 2, and our y value also equals the square root of 2 divided by 2. So now all what is left is to plug the right values into the right equations. So the sine of 315 degrees equals negative square root of 2 divided by 2. The reason why this is negative is because if we look at our positive and negative chart, we can see that in the fourth quadrant, sine is going to be negative. We know that we are in the fourth quadrant because 315 degrees is in the fourth quadrant. The cosine of 315 is going to equal the square root of 2 divided by 2 also. The reason why this answer is positive is because when we look at our positive and negative chart, we can see that for cosine in the fourth quadrant, it is positive. The tangent of 315 is going to equal negative 1. Now for the other functions, we're just going to take the reciprocals of these numbers. So for CSC, which is the reciprocal of sine, our answer is going to be negative the square root of 2. The way we do this is by flipping the fraction. So we're going to have 2 over the square root of 2. But since we can't have a square root on the denominator, we're going to multiply it both by the square root of 2, which equals 2 over 2 times the square root of 2. The 2's cancel out, so we're just left with the square root of 2. Go ahead and try this out with the remaining two functions. Then we will check our answers. So our answer for the secant of 315 is also the square root of 2. And our cotangent of 315 is also going to be negative 1. Now we are going to look at the second problem, which says 150 degrees. If we start at our starting point at 1, 0, and go negative 150 degrees, this will end us up in the third quadrant. We can see that from this point to the reference line at 180 degrees is 30 degrees. So since it is only 30 degrees away, we know that we are dealing with a 30-60 triangle. Let's go ahead and remind ourselves of the formula for this. So this formula says that when the hypotenuse is x, the short side is 0.5x, and the long side is equal to 0.5x times the square root of 3. Since we know that x is equal to 1, since we are in a unit circle, and in a unit circle the hypotenuse is always equal to 1 in any triangle, we can also find out what the other sides are equal to. The short side, which is known as y, is going to be equal to 0.5, since 0.5 times 1 equals 0.5. So we know our y value equals 0.5. The longer of the two sides, which is also known as x, is going to be equal to 0.5 times the square root of 3. Now all that is left is entering the correct numbers into the correct places. Remember that r is equal to 1. Go ahead and pause the video to do this. Then we will check our answers. Remember to rationalize all of your answers that have a square root on the denominator and to simplify them. For instance, for sine of negative 150 degrees, we will have y over r, which is 0.5 over 1. However, this simplifies to 1 over 2, so make sure to write your problem like so. Okay, let's go ahead and check all of our answers now. So like I said before, sine of negative 150 degrees equals negative 1 over 2. Cosine of negative 150 degrees is going to equal negative the square root of 3 over 2. Tangent of negative 150 degrees is going to equal the square root of 3 over 3. Now the opposites or reciprocals of our trigonometric functions. So the cosecant, which is the opposite of sine, which is CSC, is going to equal negative 2. The secant, which is the opposite of cosine, is going to equal negative 2 times the square root of 3 over 3. And cotangent, which is the opposite of tangent, is going to equal the square root of 3. In case you didn't get these same answers, please look at the chart that has the trigonometric formulas and the chart that tells you in which quadrant a certain function is positive or negative. These will help you a lot when you are solving these types of problems. The final thing we are going to do today are the problems that tell us to name all the angles that make the statement true. Let's look at the following problem. It says sine of an angle equals 0. So when is this the case? In order to solve these, we need to go back at what we talked about at the beginning of this video, where cosine is the x-coordinate and sine is the y-coordinate. So remembering that sine is equal to y-coordinate and cosine is equal to x, we need to go all the way around the graph and see where y is equal to 0. These points are at, if we look at our graph, right here at point 1, 0 at the very beginning, and also at point here, negative 1, 0. At both these points, you can see that the y-coordinate is equal to 0. So our answer is going to be 0 degrees and 180 degrees. The last problem today asks us to find when the cosine of an angle is equal to 0. So we know that cosine is the x-coordinate. So all we need to do is go around the graph and see when the x-coordinate is equal to 0. This takes place here at 90 degrees where our point is 0, 1, and also takes place here at 270 degrees where our point is 0, negative 1. So our answer is going to be 90 degrees and 270 degrees. I want to thank you so much for watching this video about the unit circle. I hope you enjoyed it. I'll see you in the next video.